You're looking at the stern of this vessel. There's a deep, clean recess carved into the hull, like a bite taken straight out of the back of the vessel. Your first instinct is that something went wrong. A collision, maybe? A botched repair? A section nobody got around to completing? It's none of those. That notch is one of the most deliberately engineered shapes on the entire vessel, and the reason it exists is hiding just out of frame. That gap isn't empty for long. It's a socket, and there is essentially one object in the world built to fit it. The bow of a particular tugboat, shaped to slide into that recess like a key into a lock. Once it's in, the tug and the vessel stop behaving like two boats and start behaving like one. So why would anyone deliberately design a barge with a hole in the back? Let's start with the original problem. What is the best way to connect a tug to the thing it is moving? For most of maritime history, the answer was a rope. A tug steams ahead, a heavy tow line runs back to the load behind it, and the tug drags that load through the water. It works. It is also full of compromises. The first is drag. Imagine you're on a pier watching a tug work. A barge on the end of a long line tends to wander, yawning left and right, shearing off in a crosswind, never quite tracking straight behind the tug. Every degree it swings is wasted energy, and the stretch of open water between tug and tow adds resistance of its own. The second problem is more dangerous: the rope itself. A tow line under heavy load is storing an enormous amount of elastic energy, like a drawn bow. When it parts, the line whips back with lethal force. Crews have been killed by snapping tow wires. So, engineers asked an obvious question. Instead of pulling the load from the front, what if the tug pushed it from behind? Cut the back of the barge into a recess, and the tug's bow slots into it. The tug can seat itself firmly in place instead of skidding off to one side, while the two vessels line up into a single, smoother shape. That recess is the notch. And that's the part I find quietly satisfying. A notch doesn't work because the tug is powerful. It works because the shape is right. The correct piece in the correct slot, and two separate machines start behaving like one. Which is also embarrassingly how I've been losing my evenings lately. Staring at 5 empty slots, working out exactly who belongs in each one. That's Raid Shadow Legends sponsoring today's video. It's a free-to-play, turn-based RPG where you take a team of 5 champions into every fight. And the one to build around right now is Grand Oak Padrig. His passive reads what each ally actually is. Attackers get attack, defenders get defense, and supports get accuracy, handing each one exactly what its type needs. Then, he heals the entire team, strips every debuff off of them, and pushes their turn meters. He isn't the piece that wins the fight. He's the piece that makes the other 4 fit. And there's a global event running too, Web of Corruption, with another free legendary in it. And that's what's kept me playing. I assumed it was about collecting the strongest champions. It isn't. Stack 5 heavy hitters and you'll lose, because nothing supports anything. It's a fitting problem, not a power problem, which I probably should have seen coming. New players using our link start with the legendary champion Karato Foxhunter, plus the epic champion Tagoar at level 15. And if you log in for 7 days, there's the legendary champion Vallaryn the Equalizer in there too, from July 2nd to August 18th. Just make sure you start the event by July 31st. Keep logging in for another 7 days to earn extra gear and upgrades for Vallaryn. As part of the Web of Corruption event, take on Raya the Mourned in the limited time event dungeon to earn pinpoint gear and other valuable rewards. Also, you get to pick one of 6 promo codes for a free legendary of your choice. BIGDAWG for Turvold, GETALICE for Alice the Wanderer, PHEMO for PHEMO the Shepro, SUPERVICTORY for Pelops the Victor, GOFAST for Razelvarg, or Wrath, and Padrig's yours. We're casual Navi in Clan the Great Cheese if you want to come and find us. QR codes on the screen and the links in the description in the pinned comment below. Now, back to notches, because getting the shape right, it turns out, is only half the job. You might assume the notch holds everything together on its own. It doesn't. Push the bow in and let go. The first wave or hard turn would shake it loose. The notch shapes the fit and stops the tug from sliding sideways. But something still has to physically lock the two vessels together. And how sophisticated that lock is defines three different kinds of vessels. In the simplest version, the tug noses into the notch and is lashed in with face wires. Heavy steel cables running from the tug's bow to fittings on the barge. The notch absorbs the sideways forces. The wires hold everything together fore and aft. It is a real improvement over a towline in calm water. But the wire is still the weak link. We know exactly what failure looks like. In July 2004, the Canadian tug Salvor was pushing a single-hull tank barge, the KTC 115, loaded with around 9,117 tons of liquid calcium chloride, through the American Narrows near Alexandria Bay, New York. The tug's steering failed and threw the rudder hard over. The sudden shock load parted the 2.5-inch hawsers holding the tug in the notch, and the tug swung violently. It then heeled hard to port and dragged backwards. The port face wire kinked across a sharp bulwark edge and snapped. The chain securing the starboard face wire parted too. With nothing left holding the connection, the barge ran aground and spilled roughly 60 tons of cargo. Investigators found the connecting rigging had never been put through the kind of engineering evaluation a conventional vessel's structure would demand. The notch did its job, the wires did not. The fix for that weak link is the second class of vessel, the articulated tug and barge, or ATB. Here, the wires are gone, replaced by a mechanical coupler that locks the tug into the notch. The dominant design is the intercon coupler. Two large rams sit in the tug's bow, one on each side. Think of them like gear-driven steel pistons. When the tug noses into the notch, the rams stroke outward and their toothed heads engage matching toothed racks running up both walls of the notch. But it is locked in a very specific way. The coupler allows exactly one movement: pitch. The tug can rock nose up and nose down as waves pass beneath the unit, while every other motion, roll, yaw, sliding, is held fast. That single degree of freedom is the whole trick. Instead of fighting the sea, the unit moves with it. The teeth run as a vertical ladder up the notch wall, so the tug can lock on at any height. Useful, because the barge floats higher or lower depending on how heavily it is loaded. The coupler constantly monitors the load it carries, and most intercon systems will disengage on their own if the pitch ever exceeds a safe limit, around 18 degrees. And that's what lets an ATB do something a towed barge simply cannot: keep pushing in heavy weather. Where a hawser tow slows down or casts its barge off, a coupled ATB rides through. Lock the connection harder still, rigid in every axis. No pitch, no flex, and you get the third class, the integrated tug and barge, the ITB. Regulators certify them as a single vessel. The tug becomes the engine room. The barge is the cargo hold. This is actually where the whole idea started. In 1950, a company called Cargo Carriers, a subsidiary of Cargill, had a matched tug and barge built at Sturgeon Bay, Wisconsin. The tug Carport and the barge G1, which had a ship-based bow and a deep U-shaped notch cut into its stern. Locked together, they hauled grain through the New York State Barge Canal and across the Great Lakes, running faster and cleaner than the towed barges of the day. It was the first true integrated tug barge. But integrating a tug and barge this tightly carried a hidden risk, and it surfaced badly in 1971, when Ingram Ocean Systems delivered two big 34,000-ton ITBs. In January 1972, one of them, the Martha R. Ingram unit, had just finished discharging its cargo at Port Jefferson, New York. The barge was less than a year old. As the last mooring line was let go in the calm of the harbour, the hull suddenly cracked clean across the deck and down both sides, and the two ends settled to the bottom. Investigators traced it not to the coupling, but to the barge itself. Steel that couldn't resist a brittle fracture, made worse by cargo and ballast loaded unevenly towards the ends. The lesson was pointed. When you weld a tug and barge into a single rigid unit and work it like a ship, every part of that unit has to be built to a ship's structural standard. And this barge had not been. The Ingram was one hard lesson in a bigger truth. A rigidly welded unit is unforgiving. With no joint anywhere to give, loads pass straight through the structure, and the whole unit is only as strong as its weakest member. That is the problem the ATB's single pitch hinge was built to solve. The articulated coupler, developed through the 1970s by Intercon and rivals like Bloodworth, let the tug and barge move against each other in one controlled axis. Just enough freedom to flex with the seaway instead of fighting it rigidly, while still pushing as one. At this point, you might be wondering whether all this engineering is worth the trouble. Well, it is. A well-coupled push beats a tow on almost every measure an operator cares about. Start with steering. With the tug locked into the stern, its propellers and rudder sit at the very back of the combined unit. The same place a ship puts its rudder, and for the same reason. The farther a steering force sits from the point a vessel pivots around, the more leverage it has to swing the bow. Then there is the fuel. Lined up nose to tail with no wandering tow and no tow line dragging through the water, an ATB moves its cargo far more efficiently than a tug hauling a barge on a wire. Operators commonly cite fuel savings on the order of a quarter compared with conventional towing. The bigger saving, though, is people. A conventional cargo ship of similar capacity might carry 50 crew. An ATB runs with around 9 to 12. Legally, it is classed as a tug, so it is manned under tugboat rules, and over years of operation, that difference is worth millions. Then, regulation lit a fire. After the tanker Exxon Valdez run aground in 1989, the United States passed the Oil Pollution Act of 1990, OPA 90, which forced single-hull oil vessels out of American waters. Operators needed a fleet of compliant, double-hulled replacements, and they needed it fast. Double-hulled ATBs, cheaper to build and crew than tankers, were the answer, and they became the backbone of US coastal petroleum transport. One last advantage: flexibility. Uncouple the tug from one barge and couple it to another, and the same expensive, crude tug can push a fuel barge today and a dry bulk barge next week. You're not buying a whole new ship for each cargo, just another barge. The notch and coupler ATBs are mostly an American speciality, moving petroleum products, chemicals, dry bulk, and even roll-on, roll-off cargo along the US coasts and the Great Lakes. For scale, while there are a fewer than 200 large ships under the US flag, over 22,000 barges are working American waterways. Some of the most interesting examples live at the extremes. In Alaska, shallow draft ATBs like the tug Aluluk and its barge Drift River reach remote river communities and bare beaches that no deep draft tanker could ever reach. Others, like Crowley's ice-class tug Avegan and its barge, Oliver Leavitt, are built to polar code standards to push through the Arctic ice. Add it all up, and these unglamorous notched units do a staggering amount of work, quietly hauling the fuel, chemicals, and bulk goods most people never think about. Think about what you know now that you didn't know at the start of this video. Nobody woke up one morning and invented the modern ATB. It all started with a rope. As engineers uncovered its failure modes, the drag, the snaps, the lost seconds, they went looking for something better. Pushing replaced pulling. A notch replaced the open gap, and wires gave way to the mechanical couplers we see in the ATBs today. Each step kept what worked and fixed the one thing that didn't. The result is a connection so good that two separate vessels can cross an ocean behaving as one, and a feature that looks, to the untrained eye, like a piece of the ship is simply missing. It isn't missing anything. That notch is a slot, precisely shaped, and somewhere nearby, there is exactly one tug built to fill it. Before you go, thanks again to Raid Shadow Legends for sponsoring today's video. Do not forget the new players get the legendary champion, Karato Foxhunter, and can pick up one of 6 promo codes for a free legendary of their choice. QR codes on the screen and the links and codes are down in the description. Thank you again to Raid Shadow Legends. If you've enjoyed this video, please make sure to click that like button and subscribe if you want to hear more about differently designed vessels. Please make sure to ding that notification bell so you stay up to date with our latest videos, and we shall see you all in the next one. Thank you for watching.